The first reports come through on the tactical displays. Radar contacts, dozens of them. They appear as small, bright points on the screen, emerging from the far edge of the map and moving inward. One in the center, then another, then another. A whole wave materializes, spreading across the display in a line that stretches from one side of the screen to the other. The entire skyline fills with tracks. Every station in the command center sees it. Officers lean forward. Operators begin calling out bearings, speeds, and altitudes. The room tightens. Nobody speaks louder than they need to. Nobody needs to. The picture on the screen tells the story clearly enough. The order for combat readiness reaches the aircraft carrier within minutes. The crew begins moving the ship out of port immediately. Deep in the engineering spaces, throttle orders ring out and the gas turbines and reactor plants respond, driving power through the propulsion system until the engines reach full capacity. The entire hull hums with it, a low vibration that every sailor on board can feel through the steel beneath their boots. Topside, the mooring lines are cast off one by one. Heavy hawsers that had held the carrier fast against the pier are released from the bollards and hauled aboard by line handling teams working in coordinated groups. Tugboats, already positioned alongside the hull, press their reinforced bows against the carrier's massive flanks and begin guiding the ship away from the dock. Their engines strain against the sheer weight of it. A nuclear-powered aircraft carrier displaces over 100,000 tons. Moving it through a narrow harbor channel requires precision, patience, and power. On the forward deck, sailors operate the anchor windlass. The heavy anchor chains grind upward from the water, each link the size of a man's torso, caked with harbor mud and trailing streams of salt water. The chains rise link by link, clanking through the hawse pipe until the anchors seat firmly into their housings. The bosun inspects the fittings and signals that the bow is secured for sea. Along the rails on both sides of the flight deck and the sponsons below, crew members stand in their working uniforms and watch the shore pull away. The port city recedes slowly at first, then with increasing speed as the carrier gains way. Some sailors look back at the buildings along the waterfront. Others stare at the people standing on the docks. Small clusters of civilians and port workers have gathered at the water's edge to watch the carrier depart. Nobody waves, they just stand and look. There is something in the way a warship leaves port during a crisis that silences people. The sheer scale of it, the purpose behind it. Everyone watching knows where the ship is going and why. The tugboats continue pushing and pulling the massive hull through the channel, adjusting the carrier's heading around each turn with careful bursts of thrust. The harbor pilot stands on the bridge wing, issuing commands to the tugboat captains through a handheld radio. The channel is narrow enough in places that the carrier's wake washes against the breakwaters on either side. Once the carrier clears the harbor entrance and passes the last navigation buoy, the tugboats peel off one by one. Each one sounds a short blast on its horn as it turns away. The carrier answers with a single deep blast from its own horn, a sound low enough to rattle windows along the shore. Then the ship moves into open water under its own power, the wake spreading wide behind it as the speed builds. As soon as the ship clears the port, the work begins in earnest. There is no transition period, no downtime. Every department on the ship shifts immediately into wartime operations. On the forward deck, sailors grab steel bristle brushes and start scrubbing the anchor chains and mooring lines. Harbor water leaves behind mud, salt crust, and organic debris that will corrode metal and weaken fiber if left untreated. The work is physical and unglamorous. Sailors kneel on the deck in the wind, scrubbing each link and each section of line until it is clean. The mooring lines are then carefully coiled according to regulation and stowed in their lockers. The anchor housings are dogged down and sealed, the windlass locked, and the entire forecastle secured for heavy seas. The damage control teams conduct their rounds, checking watertight doors, ensuring fire suppression systems are armed, and verifying that every compartment is properly sealed. In the engine rooms, engineers monitor gauges, check oil pressures, and run diagnostics on the propulsion and electrical systems. The ship has to be ready to sustain high-speed operations for days, possibly weeks, without returning to port. In the Combat Information Center, the tactical action officers are updating the common operating picture. Intelligence feeds stream in from satellites, from shore-based command centers, from other ships in the strike group. Target lists are reviewed. Strike packages are assembled. Communications are encrypted and verified. The war plan is taking shape on the digital displays, and every officer in the room is memorizing their piece of it. Below the flight deck, in the vast cavern of the hangar bay, the noise is tremendous. Metal striking metal, power tools screaming, hydraulic lifts groaning under the weight of airframes. The hangar bay stretches nearly the full length of the ship, a cathedral of gray steel and fluorescent light, and every square foot of it is in use. On one side, mechanics are preparing the helicopter squadron for combat sorties. MH-60 Seahawks and other rotary wing aircraft sit in their maintenance spots, surrounded by teams of technicians. Weapons specialists attach ordnance to the external pylons, Hellfire missiles, unguided rocket pods, door-mounted miniguns. Each weapon is carefully inspected, its serial number logged, its arming wire checked, its mounting bolt torqued to specification. Nothing is rushed. Nothing is assumed. A single improperly loaded weapon can kill the crew that carries it. Maintenance crews crawl over the helicopters with flashlights and inspection mirrors, checking rotor blade assemblies for cracks, examining hydraulic lines for leaks, inspecting tail rotor gearboxes, and testing flight control linkages. Avionics technicians run diagnostics on navigation systems, targeting computers, and communication suites. Each helicopter receives a full systems check before it is signed off as mission capable and cleared for the flight deck. On the other side of the hangar bay, the same process is happening with the strike fighters, but on a larger and more complex scale. FA-18E and FA-18F Super Hornets sit in rows, their wings folded to conserve space, their intake covers and engine exhaust plugs still in place. Ordnance teams load air-to-air missiles onto the wingtip stations and air-to-ground precision munitions onto the underwing pylons. Joint direct attack munitions, laser-guided bombs, long-range anti-ship missiles. Each aircraft is configured for its specific mission, and the weapon's loadout varies accordingly. Mechanics remove engine covers and intake blanks. Fuel crews connect hoses and top off internal tanks. Plane captains, the enlisted sailors personally responsible for each individual aircraft, walk around their jets performing pre-flight inspections with a checklist that covers hundreds of items. Landing gear struts, tire pressures, flight control surfaces, external lights, canopy seals. Every discrepancy is noted, evaluated, and either corrected on the spot or reported up the chain for a maintenance decision. One by one, as the fighters are cleared, they are towed by small yellow tractors to the aircraft elevators. The massive platforms descend into the hangar bay, accept the aircraft, and rise back up to the flight deck, delivering each jet into the wind and the open sky above. The flight deck of an aircraft carrier during launch operations is one of the most dangerous working environments on Earth. It is loud beyond description. The wind tears across the deck at 40 or 50 knots. Jet exhaust raises the temperature behind the engines to levels that can burn exposed skin in seconds. And everywhere, aircraft are moving, being towed, being fueled, being armed, being launched. Deck crew in colored jerseys work in tightly coordinated teams, each color designating a specific role. Yellow jerseys direct aircraft movement. Green jerseys operate the catapults and arresting gear. Red jerseys handle ordnance and crash and salvage equipment. Purple jerseys manage fuel. Brown jerseys serve as plane captains. Blue jerseys drive the tractors and operate the elevators. White jerseys perform safety and quality assurance checks. Together, they form a choreography that looks chaotic to the untrained eye, but operates with extraordinary precision. The first Super Hornet is guided into position on Catapult 1. The yellow shirt walks backward in front of the aircraft, arms raised, directing the pilot forward inch by inch until the launch bar on the nose gear drops into the catapult shuttle. The green shirts connect the holdback fitting and tension the catapult. Behind the aircraft, the jet blast deflector rises from the deck, a massive steel panel that absorbs the full force of the engine exhaust and prevents it from sweeping across the deck behind. The pilot runs the engines to full military power. The airframe shakes. The noise is deafening. The catapult officer, standing to the side of the aircraft, checks the wind speed, verifies the launch weight, confirms the catapult setting, and gives the final signal. A sharp salute, a point forward, and a touch to the deck. The holdback releases, the catapult fires. 270 feet of steel track accelerate the 40,000-pound aircraft from 0 to 170 miles per hour in under 3 seconds. The fighter shoots off the bow, dropping slightly below the deck edge as it clears the ship, then pulling up hard and climbing steeply into the gray sky. The landing gear retracts, the afterburners light, and the jet is gone. Seconds later, Catapult 2 fires. Another Hornet streaks off the bow, then Catapult 3, then 4. One after another, the fighters launch, each one banking away from the ship as soon as it is airborne, turning toward its assigned heading and climbing to altitude. Within minutes, a full strike package is in the air, forming up into sections and divisions, checking in with the airborne controller and heading toward the target area. On the aft section of the flight deck, a helicopter is positioned on the landing spot. The rotor blades begin turning slowly, driven by the starter motor, then accelerate as the engines catch and the turbines spool up to full operating speed. The blades become a blur. The downdraft flattens everything within 50 feet. Deck crew duck and hold their cranials against the rotor wash. The helicopter lifts off, nose dipping slightly as it transitions to forward flight and moves out over the water, heading toward its mission area. At the same time, the escort ships in the carrier strike group begin their own offensive operations. The guided missile destroyers and cruisers that surround the carrier are not merely defensive screens. They are strike platforms in their own right, equipped with vertical launch systems capable of delivering devastating firepower at ranges measured in hundreds of miles. A guided missile destroyer turns broadside to the wind and steadies on course. On the forward deck, the armored hatches covering the vertical launch cells begin opening. Each cell contains a single Tomahawk cruise missile, a weapon capable of flying more than 1,000 miles at low altitude, navigating by GPS and terrain-matching radar, and striking a target with pinpoint accuracy. The first Tomahawk fires. It erupts from its cell in a violent burst of flame and white smoke, the solid rocket booster hurling the missile upward and clear of the ship. For a moment, it climbs nearly vertical, trailing a thick column of exhaust. Then the booster separates and falls away. The turbofan cruise engine ignites, the wings deploy, and the missile rolls over and turns toward the horizon, dropping down to its cruising altitude just above the wave tops. Then another missile launches. Then another. The destroyer's vertical launch system fires in a staggered sequence, each missile leaving its cell with the same violent eruption, each one arcing upward, transitioning to cruise flight, and turning toward a different set of coordinates. The missiles streak across the sky in a spreading formation, each one locked onto a different target hundreds of miles away. On the other destroyers and cruisers in the strike group, the same scene plays out simultaneously. Missile after missile leaves the vertical launch cells. Dozens of Tomahawks are in the air within minutes, forming a wave of precision-guided firepower converging on enemy military installations from multiple directions and at multiple altitudes. The barrage does not pause. It does not slow. It continues methodically until every assigned target has a missile in flight. Radar sites, command and control centers, integrated air defense batteries, surface-to-air missile installations, communications nodes, military airfields, hardened bunkers, supply depots. Every target on the strike list receives its assigned weapon. The missiles fly low over the water, then over the coastline, navigating around terrain features, adjusting course in real time, closing on their targets with mechanical certainty. On the receiving end, the first impacts begin registering. Explosions erupt across the landscape as cruise missiles find their targets one by one. A radar installation on a hilltop disappears in a fireball. A command bunker takes a direct hit through its ventilation shaft. An air defense battery is struck before its crew can activate the system. A communications tower collapses in a shower of sparks and twisted metal. The strikes are precise, sequential, and overwhelming. Each detonation sends a shockwave rippling outward, followed by a column of black smoke that rises into the sky and marks the location of what was, moments before, a functioning military facility. Secondary explosions follow as fuel stores and ammunition caches cook off from the heat and blast damage. Debris rains down across the surrounding area. The damage is systematic and comprehensive. Back on the carrier, the catapults keep working. There is no pause in flight operations. More fighters taxi into launch position, hook up to the catapult shuttle, and launch off the bow in a continuous rotation. One aircraft launches. The next one rolls into place before the catapult has fully reset. Deck crews work without interruption, directing jets, arming catapults, sweeping debris, and checking for foreign object damage on the deck surface. The rhythm is relentless and practiced. Overhead, the first wave of fighters is already approaching the target area. They descend from cruising altitude, activate their targeting systems, and begin their attack runs. Precision-guided munitions separate from the pylons and fall toward their designated targets. The pilots pull off target, check for threats, and set up for the next run or turn for home to rearm. Meanwhile, on land, additional fighter squadrons are launching from airfields across the region. F-15E Strike Eagles, F-16 Fighting Falcons, and F-35 Lightning IIs climb out from runways at Allied bases, their afterburners glowing in the early light. They form up in pairs in 4-ship flights, establish contact with the airborne command and control aircraft orbiting high above the theater, and head toward the combat zone to join the operation. The air campaign builds rapidly. Carrier-based jets, land-based fighters, cruise missiles from the escort ships, electronic warfare aircraft jamming enemy radar frequencies, tanker aircraft orbiting at predetermined refueling tracks to extend the range and endurance of the strike fighters, surveillance drones transmitting real-time imagery of the target area back to the command centers. Everything is converging on the same targets at the same time, from multiple directions, at multiple altitudes, using multiple weapon types. The coordination is enormous. The scale is overwhelming. The planning that went into synchronizing this many assets across this many platforms took months. The execution takes hours. The strike packages hit their targets in carefully timed waves, each wave designed to destroy a specific layer of the enemy's military capability. First, the air defenses. Then, the command and control networks. Then, the offensive military assets. Each wave makes the next one safer and more effective. The operation is fully underway. The carrier and its strike group are committed. The aircraft are in the air. The missiles are in flight. The targets are being destroyed. And the cycle continues. Strike, recover, rearm, launch again. It does not stop until the mission is complete. The sea stretches out in every direction around the carrier, empty and gray, and the ship cuts through it at speed, steady and purposeful. The flight deck alive with motion and noise and fire. Above it, the sky fills with aircraft heading toward the fight. Behind it, the wake trails away in a long white line that points back toward the port they left behind, toward the docks, where people stood and watched and did not wave, because they understood what was coming. This is what a carrier strike group does. This is what it was built to do.